We have that. Like what I mean, do you guys notice that this program looks different too? To see the pens up here? You notice those are all different? There's some sort of upgrade over a break for this, which always makes me scared. All right, so the first thing you need to know, and we're going to fast track this because this was a huge component last year, is special right triangles. The first one is a 30, 60, 90. And we're not going to go through the deriving of this, but last year I did an equilateral triangle, which all these angles are 60 degrees, right. And I dropped an altitude. I said this side is 2, 2, and 2. And I dropped an altitude, and then this side became 1 and 1 because an altitude and an equilateral triangle bisect the opposite side. And then we did the Pythagorean theorem, and this became root 3. And then I changed this side to 7. 7. No, I probably didn't do 7. I didn't feel like fractions. So 8, 8, 8. That made this 4. And then lo and behold, this became 4 root 3 when I did the Pythagorean. Do you remember this? Okay. So therefore, we derived that. I just said I wasn't going to derive this, and I yet again did it. I said, okay, for any 30, 60, 90 right triangle, we'll call this side A, this side A, wrong, this side A root 3 because that was opposite the 60 degree side, and then this side was 2A. Okay, so if this is the 2A side and this side is 6 root 3, then what does that make this side? 3, 2, 1, go? 3 root 3, half of that. And then it gets a little bit hairier here. This one's a little bit tougher, but now this is the A side. This side is whatever this side is times root 3. So this is literally wrong. I had A in my head. 3 root 3 times root 3. What's root 3 times root 3? 3. What's 3 times 3? 9. I don't even remember if I wrote that last period. So these are the actual missing values. You can't use the Pythagorean theorem. You have to know this relationship because there's only one side given, right? Okay, so they went right to the hard ones because this starts with an R and there's a V in it. What's the word, everyone? A word that has an R and a V in it, and it's something that you've seen before is the holy jeez Louise. Review. I was looking for the word review. Anyway, let's go to this one. Oh my gosh, what a day. They're actually in revolt right now because they were betrayed by coming into school earlier to take an ACT that was bogus. Anyway, do the same thing. This is a. Well, they're not going to answer because they're in revolt right now. So what would this be? They're back. ARA 2. And again, it's because of the whole ISOS. I'm not right. I'm not even doing it. No, you're supposed to have this. It's called what? Review. Okay, so now here's the problem. We gave a hard example because this is review, so they went to the worst types of scenarios, not just given one of the these. By the way, this is isosceles, so these are equal. So what do I do when this is the ARA 2 side and it is 7? Well, you know what? We got to speed up. You set them equal, and then you solve. And then you rationalize. And you should know rationalization from earlier in the year or last year. Okay, you multiply top and bottom by root 2, and you end up with 7 root 2 over 2. Honestly, though, the AP exam doesn't really care too much about rationalizing. They don't. Okay, so you might have been able to leave it as 7 over root 2. But we're going to rationalize and probably hold you to rationalizing, denominators. We're going to do that. And then is this a 30, 60, 90? No. So what do I have to use? I just said it before. Pythagorean theorem. I know I'm going over this fast because this is review. This is the hypotenuse. So it's a squared plus b squared equals hypotenuse squared, c squared. 4 squared, 16. And then, I should have wore Pythagorean theorem today. I have a Pythagorean theorem shirt. I wore this shirt instead to tick off some English teachers. Oh, wait, I can't get all the words in there. Math is importanter than English. Get it? You take them off twice by saying math is more important, but then use a bad English word. Right? By the way, when I square root both sides, what am I supposed to put in front of that answer? Plus or minus. But you know what? This is real world. Real world. A triangle. It's not in a coordinate plane, which it was last year. We went into coordinate plane trig, and then that's when we had to select, was it positive or was it negative, because they were coordinates, left, right, up, down. And we're going to get into that. Okay, but we're in real world. All right, so here we go. We saw that in the Get Triggy with a video, so katoa, right? Oh, here we go. I'm gonna take a risk and get in trouble again, because I already got in trouble for some of my videos this year making jokes. All right. So what did I say last year about sinus? So people I had last year, what did we call cosecant? A what? A hoe. All right. Sinus so cosecant's a what, everyone? Say it. A hoe. And you know what? Anything I need to do to get you to memorize something, I don't care what it takes. That's not nice. No, I was going to say, so I won't say the next joke I was going to say. I don't want to get in trouble. All right. So cosecant's a hoe. It just means that cosecant is the flip of sine. Because it is a flip of a coin sometimes. Which one is it? Cosecant or secant? Hopefully now you know. All right. So then what's cosecant? Ka. So that makes secant ha. All right. It's just the flip. They're just reciprocal identities. And then come on, toa. Cotan is AO. It's just the flip of cotan. You can't screw up cotan and tan being related. How could you? All right. And then unfortunately, we got to do this. I wanted to insert this in there for you so you didn't have to write all these. Go ahead and this is what it means, finding all 6 trig functions. Let's just get them set up. And then I gotta, to write them ourselves. Sinus, cosecant. Oh, I'm going to get in so much trouble. I'm waiting for it. Cancel Mr. Samuelis. I'm just waiting to get canceled. Why did the chicken cross the road to get to the other side? We own chickens. You can't make fun of my chickens. Everyone gets offended no matter what. Can't make jokes anymore. Job is getting less and less fun. All right. So here we go. Let's call this, I want to call it, I guess I'll just call it X. But I don't want you to think about last year, X, Y, R. Hey, you guys remember Sir Kicks or Ticks, by the way? How many people remember that? Only my people. I did Sir Kicks or Ticks. Because when we get in a coordinate plane, we have X, Y, and then R is a radius. Now, you're going to get into that with Mr. You're stuck with me now. So people I had last year get to hear it twice. So X squared. Oh, you're stuck with me. I'm sorry. All right. Someone changed the semesters, and she's crying over there. Can I have my old teacher back? Anyway. Are you kidding me? Is this root 3 again? Right? Isn't it root 3 again? Root 7 squared is 7. 2 squared is 4. 7 minus 4 is 3. And then root 3. Are we in the real world or in a coordinate plane? Real world. So I don't care about the plus minus. I do want to keep mentioning it, though, because people always forget to put plus minus in front of square rooting both sides questions. All right? So I'm worried about that. All right, and then unfortunately, we got some rationalization. By the way, here is the angle. So it is the reference angle. So what side is this? Yoink. This is always what I found, little Danny in high school. What side is that? That's the opposite. Well, maybe little Danny also found this first, because what is that no matter what? Hypotenuse. So I always found the adjacent side last. But I will tell you what the adjacent means. It's English. Adjacent means right next to. It does. Okay, and it's the side that, not the hypotenuse, but the other side that's right next to the angle measure. So it's a little bit unique. So sinus, yes, we're going to have to rationalize. But really, do we? AP exam doesn't normally care. And then cosecant, don't flip this. Flip this, because then if you flip that other thing, you're going to get in a rationalization thing again, and then reducing, and you'll still end up with root 7 over 2. Okay, just remember I said that. I'm not going to go into that any further. Why? Because this is review. What? Oh, I thought he said another R word. All right, and then ridiculous. All right. This is root 3. This is a little bit different. So this is root 3 over root 7. And then I'd have to multiply top and bottom by root 7 because you have to clear out the denominator when you were told you have to rationalize last year. But then, you know what? I don't really want to flip this. I'm going to just go ahead and do secant, which is root 7 over root 3, because I have both of them as radicals. And then this is still pretty easy to rationalize. I guess it would have been fine. 7 over... No, I think you would have had to reduce after. If you flip the root 21 over 7, it would have rationalized and then reduced, and it would have been a little bit longer. Okay, so again, this is review, so we're coming up with more of the challenging questions. 2 over root 3. So with that's, come on, 2 root 3 over 3, multiply top and bottom. Do not flip this, flip that. And you may have remembered this ratio from last year, but that was not a ratio for cotangent for our special ratio. Anyone remember root 3 over 2? 1/2 root 3 over 2, root 3 over 3, 2 root 3 over 3. Anyone? Okay. Yeah. Oh, you know what? And I only did this one last hour because I was running out of time. Get Trig with a video. Are you okay?
Yeah.
Oh, I thought, okay. Okay, A is 2. Is everyone all right? Who said no? Are you still mad about? Okay, B equals 8. All right, and then, yeah. I mean, let's think about this one. B is 10 degrees. If angle B was 10 degrees, what's angle A? What's angle A? What's angle A if B is 10 degrees? 80. Then you could use trig, and it's just, that one's easier. This one's a little bit harder. Not really, but it is. I don't know. They're about equal. But so how would I find C? The anyone? Pythagorean. I should have wore that shirt. Yeah. I may have wore it this year already, but it would maybe next week. 2 squared plus 8 squared, or maybe when the other classes go into this in 3 weeks. No one really cares about your shirt, Mr. St. Louis. 2 squared is 4. 8 squared is 64. Isn't that 68? And then I'm just going off of last hour. I did know 4 went into it, and I couldn't remember what the other number was because my brain has been abused today on a Wednesday. You think you had it bad? I would have rather had your morning. Let's not get into that. What's the square root of 4? That's why I did this. 2. 2 root 17, right? So, sorry. In my blabbering and talking about my shirt and all this other stuff. This is what it means to solve a right triangle. You find every single missing part. Okay? All right, so 2 root 17. And we can put that up there, write it. It's right here. You got it listed and circle it. I'll change colors for our next part, maybe green. Oh, I don't know. It's just I'm closest to this one. What side is this? Let's use our given. What if we made a mistake on this? Let's use our given only. Plus our given doesn't have a radical. So that's nice. What side is that? What side is this? So what am I dealing with? Tan. Now this is the get triggy with it video. You pick tan. That was the beginning. You watch that video and learn everything you need to know about trig in a flash. Everything you need to know on basic trig, except for word problems and stuff, but the basics. And that equals opposite 8 over 2 adjacent. Sorry to think of my word. And then get triggy with it. Even showed you this. Whatever you do to one side, say it. So you should never have to ask me this because you're paying attention. You're not a bum. What do I do? Tan or inverse tan? Well, I just showed you. The way to get rid of that tan in front of that angle B is the inverse tan in front of it. Those are opposite operations. They cancel each other. But whatever I do to one side, do it to the other. So you inverse tan ratios to get angle measures. Oh, no. Get your calculator out or don't. But you better make sure you understand this. I probably more than likely second NEM'd 712, you guys. At some point last semester. I probably did. So probably everyone in this class is in radians. Now, people know from me last year what a radian is. I think the other Math 2 honors teachers didn't show radians. And that's okay. Math 2 honors is not showing radians ever again. They've been told not to by the Math 3 teachers us. So you have to go to your mode, and then go down and turn your calculator into degrees. By the way, I may be a liar. How many people do trig in science, their science class right now? All right, so you already know about this, but I got to worry about everyone that maybe are not in that. Okay, because otherwise you will not get the right answer. Tell me what the right answer is. What's angle B? Point? Isn't it 0.9 something, like 9? Not 9.
No, it's 75.9.
Oh, 75. I wanted like 2 decimal. You know what the usually go 3 decimal places in the but anyway, do me 2 decimal places. Okay, that's what. Okay, and that's degrees. Now, honestly, what can we do to find angle A? What can we do to find angle A now? Well, or 90 minus 75, right? Okay, but you know what I like doing, just in case I made a boo-boo? I go ahead and say, all right, you know what? I'm going to find this angle measure by trig as well because it's easy. Now, that's the opposite side, and that's the adjacent. So tan of A equals 2 over 8, and then I could just inverse tan that. And then I should get, I don't want to embarrass myself, but I think it's 14.04 degrees. Is that right? As long as that tan says so, then I know I'm good because those add up to 90, which they should. All right, everyone good? Remember your trig? By the way, in the ACT, probably not today's because it was a disaster, but usually there's 4 questions that deal with what I just did up there. Even secant, cosecant, cotangent showed up. I saw on a practice SAT or ACT. Hard to keep those 2 out of my head there. Okay, now this always blows my mind. This is like reading, I guess. A 14-foot ladder is leaning against the wall. You got to be able to draw that. So I'm not going to draw the ladder, but I am going to draw a wall. And here are our assumptions we have to know about the wall. We have to know that the wall is not the leaning tower of Pisa. We have questions like that when we deal with non-right triangles, meaning it's straight up. And we have to also assume that the ground is perfectly horizontal. Is that true all the time? No. But in math, in these questions, it's assumed to be. Got it? Okay, so we have to make that assumption unless it's written in there differently. Okay, so we make that assumption, and then here's the ladder leaning up against the wall. So we really could draw a very boring triangle as long as we know what everything is. Wall, ladder, and then ground. I don't know. Okay? And it's a 14-foot ladder. So where does 14 go? W, G, or L? Which one is it? It's L. It's the stinking ladder. And this always drives me nuts when people put 14 in the wrong spot. It's leaning up against there. So this will be shorter here. All right? Shorter is a value. All right? And then the base of sometimes they say the foot of the ladder. Does a ladder have feet? No, but sometimes they say that. Where are the feet? At the bottom. Okay? Is 3 feet from the base of the wall. So this is 3. I was about to ask you, what's 3 then? G or W? Come on. All right? And then I made a mistake. I didn't even listen to myself. What angle does the ladder make with the wall? So what angle is that? Top or bottom one? Which one is it? Top or bottom? I didn't even read. I didn't read. I just I threw X down here last hour. I embarrassed myself. Okay. All right. So with all that given, what is, and then that's it. What is the angle? So what do I use? What side is this and what side is this? So what trig function? I heard you say it. So what trig function then? Sin. There's no sinners in a pub. Not in this school because nobody gets in trouble ever. There's no consequences. Anyway, sorry, it made me go there. What do I do? What do I do then to find this answer? Inverse sine. You don't have to do whatever I do to one side, I do to the other all the time. It's a good way to save yourself, though, if you are not paying attention right now. Okay? Anyway, yeah. Oh, okay. Then we're not going to be drawing cliffs and so on and so forth. But a person in a small boat, fine. For your enjoyment, I'll draw a boat. There you go. Okay. Person in a small boat offshore from a 100-foot vertical cliff sights a hawk on the top of a cliff at an angle of elevation. Here we go. I'm going to be able to. Didn't I do this in this class? Because last hour said no. Maybe they just. Didn't I do this for an angle of elevation? I got to put this mic so you can see me here. Didn't I do this? But then you got to be able to see me. Didn't I say for an angle of elevation, it's the. Was this you guys? Didn't I do this with my arms? Was anyone watching me yesterday? He wasn't. He always got his earbuds in. Never follows the rules. All right. It's the difference between a horizontal line of sight and looking up. Almost nobody screws up angle of elevation. But coming up is going to be an angle of depression. It's the same thing. The difference between looking horizontally out and down. It's this angular displacement. That's an angle of depression. Elevation, depression. Just wait. Okay, so angle of elevation is 25 degrees. Okay, let's draw this cliff. Let's make it a little cliffy-like. Then here's like the beach. Here's the water. And then here's the ground. And then here's the cliff. And then here's the bird. I can't draw a bird. I don't feel like drawing a bird. I tried last hour. I embarrassed myself again. Okay, so we're pretending that it's like right at the base of the water for the angle of elevation. I think you're far enough that you can say that. All right, and then that's going to be 25 degrees. The line of sight straight up to the bird from there to there. Okay, and then here are our assumptions. Well, the water is not an assumption. Of course, that's horizontal. No matter where you're at, the water, except if it's wavy, but on average, the water's perfectly horizontal, so we're good to go on that. And then I forgot to put this in there. That's 100. How far offshore is the boats? Well, that's easy. That's this. Okay, that's to the base of the cliff, right? So that's what X is. All right, once you make the drawing, the trig is easy. What is it? Sine, cosine, or tangent? 3, 2, 1, go. Tan. Gave you 3 seconds to analyze that you had opposites over adjacent. I always get people that half pay attention or 1/8 pay attention. How did you get tan? Go back to the Get Triggy With It video and show how you make the choices and why SOHCAHTOA is the acronym. All right, and then in the Get Triggy With It video, it's switch the X with the tan 25. It really has a whole thing about cross multiplication, and then you get tan 25 times X, and then you have to divide by tan 25. So if you think about cross multiplying, that's where you end up anyway. Right? And then you type it on your calculator and we move. Let's go to that angle of depression one right away and then come back. So here's an angle of depression. Now there is something really tricky in this question. It caused me a pause. I didn't unfortunately look at this before doing the notes because I knew it'd be fine. I had to reread a couple times, and you're going to have to do that. Okay, but just make sure you understand that. An airplane is flying at an altitude of 6,500. Okay, I get it. You can draw an airplane. This is a really good one. Of course, if I put a head there, then it just looks like someone swimming or something. But anyway, and let's say we're talking about angle of elevation or depression. So let's put it at right at the where the air. What's the person that flies an airplane? Pilot. The pilot is looking at, and then that's 6,500. So it's straight down to the ground. Okay. If the pilot wishes to land with a 12-degree angle of depression, and I went through this with the last hour. You ever see a cockpit? And you see like how many instruments are in there? So many instruments are going on. One of the instruments is angle of depression, but some of the instruments are vectors. How many people have heard of vectors from science? Wind vector. The Earth is actually moving. I'm sure there's a minuscule amount of data about you're flying, but the Earth is moving to make sure that I land exactly in the spot. All these instruments are calculating. They're all basic math in all instances, but they're all working together. And one of these is the basic math going on. I want you to understand that, like how understandable engineering can be, but it's just a lot of things going on at once. And that's what we're trying to teach you in a high school environment. All right, so the angle of depression. But this is where I got how far from the airport. Well, there's two things. See, I know I have an angle of depression, so I know I'm going to be going down to the airport. So here's the airport. So right there is where we're landing. We'll call that the airport. That's that spot. Airport, can't spell. But what are we talking about here? Are we talking about this distance? That's the direct distance from the plane to the airport, right? So if we're going to go along this line as we depress, that's a distance. Or is it this distance where you're horizontally, located compared to the airport? Read that, look at the parentheses, and tell me, is it top or bottom? Where do I put X? Let's see what you get. 3, 2, 1, say something. It's the bottom. The ground distance means the horizontal distance from the plane to that's another way of expressing this. How far is the airport horizontally from the plane? That means direct horizontal straight across, not the direct distance from the plane to the airport. That's tough. So because of these words, that's where X is located. Tough. I had to read that a couple times to make sure I was right last hour. All right, but then here's another problem. What's the angle of depression? Last hour, I made a silly mistake in this question. It's not even worth answering because I made a mistake anyway. Well, here's what I got to do. I got to complete this, and what's smart on this is to make a rectangle out of this. Oh, this don't like that feature. Okay, so I make a rectangle out of this. Just bear with me. So this is 6,500. This is X as well, right? Right? Everyone's good with that? Now I ask you, which one's 12 degrees? Is it here or here? Let's say top or bottom. Bottom or top? Which one is it? 3, 2, 1, go. Top! It's this difference between horizontally looking out and looking down. It's that angular displacement. Elevations and depressions are always off of the horizontal. Anyone that puts 12 right here, you're gone. You're instantly getting all credit off. I make a big deal about this every year, and almost 50% of the students still miss it. And it does make me angry. I don't know why, because I don't think it's hard if you just look at my arms. Okay, anyway. Got it? All right, now after all that, it's easy. What's the trig function? What's the trig function? Seems like our popular one, right? Tan been used a lot in this. And last year I did a big deal about this. We had a dog and a bird and a tree. Anyone remember those notes? Are you having a flashback? The dog is looking up at the bird and the bird's looking at the dog. And then I made a whole presentation about, I made this presentation that if you're at the airport looking up to the plane, then this is the angle of elevation and they're equal. Do you remember that? I actually told you guys last year, if you have an angle of depression question, turn it into an angle of elevation. Plane to the airport, make it airport to the plane. They're equal because they're alternate interior angles. All right? Did all that stuff with you. That's a get triggy with a video. Switch these two and then press it on your calculator. Okay, at this point, I was almost up. What time do we got here? We get out at 20. I think I'm going to end in the same spot. I'm going to do this one, and then this one's really hard. And then this one is not as bad, but it's just a multiple step question. I think you'll be okay without me. I don't even think this one ends up in the homework. All right? What just happened there? Okay, so find the altitude of an isosceles triangle. Hey, this was the whole part of our kind of our deriving last year of those special triangles, except we had equilaterals. So, but an isosceles triangle means these two are equal. So you got to know that definition. With a base of 184, I'm going to put that way down here because I'm going to do something else with that. And the angle opposite the base is 68. Oh, find the altitude. I skipped that part. Here's what an altitude is of an isosceles triangle. It is the height coming from the two equal sides angle. I forget what that angle is called, but anyway. And that's a 90-degree angle there.
I don't think I put that there. So this angle is 68 degrees. The angle opposite the base is 68. I'm not going to write that, though. I'm going to write 34 and 34. Because here's a relationship you should know. In an isosceles triangle, the altitude bisects. It also bisects this bottom side. So is that 92, 92? Right? That's why I gave some space there. Sure, someone said. 90, 90, 180, and then 2 plus 2 is 4. Okay, and I think I have everything I need. But you know what else I did? I also found these two angles because this is all 68. And what do you know about these two angles? They are the same. So I do 180 minus 68 and then divide by 2. And I think I found these, or someone found these to be 56. Does that sound right? Does that all add up to 180? So these are all things we can mark up on this, and now we have choices what we can use. But I need to find the altitude, and I'm going to end on this. So that's x there. So I have a choice now. I could easily use 34. Let's start with that. Oh my gosh, what are we using yet again? Tangent seems very popular. I think I'm just going to use tangent all the time in my homework. So that's 92 over x. We know to switch those. Or if I used 56, I'd use tangent again, but it flip-flops who's the opposite and who's the adjacent. Okay, we have a shortened day. I don't think this was an old one that we used to do all the time from our old pre-calc book. But then the law of sines and cosines actually, do you remember the law of sines and cosines? We could actually use the law of sines and cosines to find that one really easy. So it kind of became that irrelevant in that question. I just ran out of time on this one. I'm not going to say anything. By the guy, you guys did blabber. Someone did blabber. The other classes knew. Well, Mr. Samuelis gave the grades right away of the practice exam. And I go, I told you guys to not open your mouths about giving the exam yesterday. And somebody did. Okay, you guys can't help yourselves. You just can't. You got to let the cat out of the bag, don't you? But anyway, let's go to the wait, what did I just do there? All right, here we go. Let's look at that calendar that I showed you and then just show you that the assignment. Oh no, I lost it. I didn't bookmark it yet. Bookmark your calendar. I'm going through the same problem right now. I'm really fumbling now, hitting all the wrong things. Yep, there's the calendar. Okay, the book is right there. You have to hit this to open up the book, right? How come that's not open? Open. There we go. See it? See the questions? Okay, so put them on a separate sheet. And then some of the key is right. Some of these worked out and some of the answers are written there. Got it? But you ain't going to get a whole key, so hopefully you can check with your friends. All right. Hasta la vista, baby.